Hello. In the previous lecture, we talked about the memory hierarchy and the broad classification of memory and the performance analysis of memories, the concept of hit rate, miss rate, and things like that. Now we move on to specific concepts of memory. How they are built, how they are used, things like that. Okay, so first of all, when we talk about a memory, so what is a memory? It is an element, right? It is something that can hold data, and data being bits, ones and zeros, which will have a certain word length, meaning each word will be having certain number of ones. For example, if you say the word length is 8, then 8 bits, 8 zeros or ones will be one word. So memory is an element which can store or retain certain number of words of data, and because there are multiple words or bytes of data being stored, we have to use the concept of address to know where this data is actually stored, right? So that is, address is one of the inputs of a memory array or a memory element. And the other thing is that there is an input output line. This is shown as one line, but usually it will be separate. Two separate lines will be there. We'll come into that later. And this line will be of the number of bits of this line will be the word length usually, right? So here it means the line is m bits wide. That means the word length of this particular memory element is m, right? And here the address is n bits wide. N bits means the capacity of this memory is 2 power n minus 1. Sorry, 2 power n. That is 0 to 2 power n minus 1. So consider this example. We have a memory array which has 2 address lines and 3 bit wide data line, right? So it means it can have a maximum of 4 locations, and the data width or the word length will be 3 bits. So this is how it will be. It will have 4 address locations because it has 2 bits and for the address, and 2 bits of address can have a combination of maximum 4 types, right? So 0 0 0 1 1 0 and 1 1. If it was 3 bits address, then it would have been 0 0 0 to 1 1 1. That there would have been 8 combinations or 8 memory locations. And each location, see this location is a what can you say, memory word corresponding to each address, right? So this 0 0 is a location and it has a certain memory or word stored in it. 0 1 is the address location, memory location, and there is a word stored in it, right? So and each word is having a length 3 bits. So this is a width of the memory and this is the depth of the memory. Width means what is the word length, how many bits of memory can be stored in one location. Depth is how many locations are there. So when you are talking about the capacity of the memory, it is a 4 by 3. That is depth by width. So it is a 4 by 3 memory. 4 by 3 watts, 4 by 3 bits. Okay. So this is a more general and practical memory. So this has a 10-bit address line. That means it can accommodate 2 to the power of 10. That is 1024. That is 1024 address memory locations are there. And that is 1024 words are there. Okay. And each word is what? How many bits? 32 bits wide. So this is a 32 by 1024. 1024 is 1K. So this is a 32 kilo bit array, right? This is a 32 kilo bit array. If you are talking about bytes, how many bits is 1 byte? 4 bits. So this is how many bytes? 8 bits is 1 byte. This is 32 bits, right? 32 bits means it is a 4 byte word. That means this whole thing is 1024 into 4 bytes. That will be 4 kilobyte. Here it is 32 kilobit. So this will be a 4 kilobyte memory, right? Now let's go back to our 4x3 memory array. So how is it internally arranged, or how is this memory array implemented? We have to see that also, right? So here there will be a decoder, and the address is given to the decoder. So what happens when you give an input to a decoder? Depending on the value of the input, one of the many output lines will be selected, right? One of the many multiple output lines will be selected. Suppose here our input is 10. So that means this will be selected. This output 10 output will be selected. This output is called as a word line. See, the lines connected to each output of the decoder, 11100100. These lines are called word lines, because every word is not every word, each word, that is the 00 word, this word is, the bits of this word is connected to this word line. So if you want to choose, if you want to select this word, you have to select this line, right? And once you have selected this line, what happens? The stored bit, this single bit, this is a single bit, okay? All these boxes are single bits. So this single bit is selected, this single bit is selected, this single bit is selected. Similarly, if you are choosing 10, that means this line will be active, and this bit is selected, this bit is selected, this bit is selected. Because this is a decoder, if you select this line 10, every other line will be deselected, right? So that means all these will be inactive, these won't be selected, only the bits connected to this particular word line will be selected. And once they are selected, how do you read the data or write the data? We use the bit line, right? Use the bit line. So for a 4x3 memory array, there will be 4 word lines. Number of word lines is equal to the number of memory locations, right? For a 4x3 memory array, there will be 4 word lines and 3 bit lines. Number of bit lines will be equal to the word length. How many bits are there in a word? So once more, the single bit storage element of a particular word is connected to the particular word line, right? And all the bits corresponding to a specific location, that is bit 0 of all the words, are connected to bit line 0. Bit 1 of all the words are connected to bit line 1, like that. So this is how the internal arrangement of a memory, here in this particular example, 4x3 memory array looks like. So the takeaway from this should be, the address is given to a decoder, and from the decoder word lines are going out. The memory, the single bit storages of each word is connected to the corresponding word line, and all the bits corresponding to a certain bit location is connected to the corresponding bit line. Okay. Earlier we showed the memory as an element having just one input, or one address input, and one let's say data input output, right? But here in this example, we are showing a multi-ported, that is here it is a 3-ported memory system. That is, here we have 2 ports to read and 1 port to write. That is, A1 is the address port used to read from the RD1 port. That is, whatever address you give to A1, the content of that address will be read from the RD1 port, and whatever address you give to A2, the content of that address will be read from RD2. And if you want to write something to the array, you have to address that location using A3, and the content to be returned to the memory should be given as WD3, right? And this WE3 is for the write enable, to enable this writing into the memory, and this is the clock input. I hope you will remember this is similar to the memory or the register bank that we used in the microarchitecture in the data path of single processor and multiprocessor implementations. Okay, till now we have been talking about how this different single bit storage elements are connected together to form an n by m memory or something like that, right? We were seeing how a memory array is organized and how they are accessed, what they are called and things like that. So now we will see this part, the actual storing part, how memory is stored in the data, how data is stored in the memory. That part we will see in the next lecture. Thank you.